Hi, and welcome to another episode of the Xylos Cloud Chat. My name is Tim Jacobs.
And I'm Geert Baker.
And today we're going to talk about the building blocks for real-time analytics within Azure. Now, Geert, the value of data is both in the historical data that you collect to aggregate the data to have some dashboards about what happened in the past, and also in, let's say, the real-time aspect of data. You need to be as close to the event that generated the data as possible. So we're looking for some way to combine both this batch analytics for processing large amounts of data and, let's say, to have a sub-second data pipeline that we can use for real-time analytics. How can we combine this?
There's something which is called Lambda Architecture. And to keep it simple, it's in fact a system that takes in data real time, does something with that data in real time, but also keeps the data for historical analysis afterwards or batch analysis afterwards. The system can be relatively complex. There are many components you can choose to build this architecture. For further information, I can recommend the book Big Data by actually the person who coined the term Lambda Architecture.
Now, of course, the question is, how can we do this in Azure?
Well, there are, of course, several options within Azure. We divided those into two main choices you can take. The first one is Stream Analytics. It's Microsoft's offering versus the HDInsight offering, which is built on the Apache stack of software. And of course, what's the difference between the two? First of all, Stream Analytics is a multi-tenant service, where HDInsight, these are servers you deploy for your own personal use. And of course, there's a cost difference between the two. Typically, with Stream Analytics, the cost is lower than with a full HDInsight offering. Now, the extensibility is a big difference between the two. Stream Analytics has low extensibility. You cannot really write custom code within this model. With the HDInsight offering, this is all about writing code. And you can write your own business logic for your specific needs. Of course, it's fully open source. For some people, that can be very important to have this open source stack implemented. Within these real-time systems, dashboarding is also quite important. Microsoft has a nice visualization offering with Power BI. Within Stream Analytics, this is a native component. If I'd like to stream real-time data to a dashboard, I can just do so with a few clicks. That's not so simple within the HDInsight offering. You have to either do it programmatically using some APIs, and in some parts of HDInsight, this is offered. For example, in Spark, there is some integration with HDInsight today.
Okay, great. HDInsight is based on the Hadoop stack. So are there multiple choices that you can make there?
Yes, there are indeed multiple choices. Now, the Hadoop stack, of course, is very large. It's like maybe like hundreds of components that you can actually choose from.
Yeah, it's really a zoo.
Indeed, it's a zoo with all kinds of funny names of funny animals and stuff like that. Now, within HDInsight, Microsoft is basically offering 4 different deployment options. So you can either deploy, let's say, the standard Hadoop stack. You can deploy the HBase database, NoSQL database. You can deploy Storm for real-time processing, and you can deploy Spark. And usually within the HDInsight offering, you can choose between either Storm or Spark. Within the Apache offering, there are even other components, like Apache Flink, for instance, which is relatively recent. Today, you cannot deploy this within HDInsight as a service, so to speak. The choice between Storm and Spark is kind of a delicate choice, but basically Storm is record-by-record processing, and it really has very low latency. And for some applications, sub-second latency is very important. So in that case, you should use Storm, and it's used in many environments for that purpose today. Spark takes a bit of a different approach. It does micro-batching. By the way, Storm can also do that with a Trident API, but with Spark, that's the only thing it does. And micro-batching is basically batching up several records in some time frame and then doing an operation on that whole batch at a time. That results in higher latency. So again, depending on the application, that might or might not be a good fit. Now, a big difference between the two is that Storm is dedicated to real-time processing. Spark is a framework for multiple types of workloads. So it can do batch and it can do streaming. So if you standardize on Spark for these multiple workloads, you can actually reuse all of the APIs you use in batch within the streaming environment as well. When it comes to maintaining code base, you can actually have the similar code bases. A very important distinction is in Storm you can use .NET. So the developer can actually use Visual Studio and develop his topology for processing within the Visual Studio offering using C#, for instance. With Spark, you're going to use Scala or Java or Python.
Okay, great. So can you show us what this is about?
Yeah, we're going to do two demos. First one is the Azure Stream Analytics demo, and then for the HDInsight offering, we're using the Spark offering. Okay, so first some context about the setup of the demo. We have a small console application here which is connecting real-time now to Twitter. It's retrieving tweets about certain topics. We're calculating a sentiment score, how people express themselves in that topic. Is it negative? Is it neutral? Is it positive? And we're sending all this information to an event hub in Azure. There the data is waiting for a stream processing application to retrieve it. Yeah. And so the first solution, the Azure Stream Analytics, you can see here in the screen in the Azure portal. Basically, what this component is doing, it's using the event hub with all the tweet information as input. We're doing some real-time processing on that data, and we're sending it to two outputs: a Power BI dashboard and a DocumentDB database for historical analysis or later batch processing effect.
So DocumentDB is a NoSQL type of database without a schema, so you just dump the tweets in there and then you can process them later.
Yeah, indeed. Just one example, I could also have written tweets to a file in storage, for instance, but the DocumentDB is natively integrated within Stream Analytics. There's just a few checks you have to do, and you're logging that data to a database. Now, the real logic is within the query that is being written, and the Azure Stream Analytics component is just using SQL or some SQL-like language. We're doing two statements here. The first one is selecting the topics of the tweets and is doing some counting and some averaging of the sentiments, and then sending, let's say, in a batch of a 5-second window, the grew by tumbling window there, is sending that data to a Power BI dashboard. This is the Power BI dashboard that we're building on the real-time dashboard. Yeah, the other part of the query is just dumping it into a DocumentDB database. And you can see how simple it is here. I don't have to write code to connect to DocumentDB and to push an item into DocumentDB and so on. This SQL statement is all that is required to simply put that item we received from Twitter within that database. It's as simple as that.
So, but you're also limited to the functions that are contained within this SQL-like language within Stream Analytics.
Absolutely, and that's the big difference, of course, with the HDInsight offering, where I'm going to have to write code, and I can write whatever I want in that code. So I deployed a Spark cluster here. I'm just using 3 worker nodes of the D14 type. Yeah, they have quite some cores, so in total I have 56 cores. Depending on the application that you write, you will need more or less.
But you say you're deploying VMs. Does this mean that you need to do this yourself, or does Microsoft provide some kind of managed service around it?
Yeah, this is an as-a-service offering. When you deploy an HDInsight cluster, in this case a Spark cluster, you just define the amount of management nodes, 2 management nodes, and a number of worker nodes. It's then deployed for you. You don't have to deploy servers yourself. You don't have to deploy or install Spark and maintain it and so on. Microsoft is doing this for you. There's a 99.9 SLA, uptime SLA, and so on. So that makes it easier to deploy these solutions in the cloud. But let's take a look at the code we have written to get our tweet data within Spark. And here we're using the Zeppelin notebook. This is one of the possibilities to interact with Spark when you're doing prototyping. This is not really the application, but when you're prototyping, seeing what you need to do in code, you can just type it in here and see what the results are. In this case, we're also connecting to Azure Event Hubs, and Microsoft provides some code, some libraries to connect to an event hub and get the data out. And as you can see here in this section, you see that we connect to the event hub by name, we specify credentials to connect, and so on and so on. Then the other code, we're not going to go into detail in the code, but you need something which is called the streaming context. You have to set this up, and you have to also tell the streaming context, what are you going to do? And basically, the code you see here is nothing more than, okay, take this message that you receive from the event hub, do something with it, and in this case, in the end, you are registering a temporary SQL table with an then query using a SQL statement. There are other ways to do the querying. SQL is just one of the options that you can select. Then when we start our streaming context, basically that SQL environment is ready to be queried. You can see this a bit further. If I'm going down here, there's a SQL statement, show tables, which tells me what tables I can use. And we have registered the tweets table within the system. So here is the SQL statement to actually take a look at the tweets that are coming in real time. I'm going to click here to run this SQL statement, and you'll see some changes here. And you will see new data has come in into the system. Depends on, of course, the real-time data. It's clear we are just prototyping the application in this notebook environment. Do exactly the same thing as in Stream Analytics, where a continuously running application that is doing something with the real-time data. I would have to deploy code on this cluster, let this code run continuously in a distributed fashion, and then we have an application running within this environment that is doing what you need to do with your custom business logic.
And you can probably also visualize this again with Power BI.
Yes, you can. But of course, you can see it here. You will have to write some code to connect to Power BI and dump the data in there. Or for instance, like in Stream Analytics, where I'm writing to a DocumentDB database, here I would have to create some code, write some code to connect to DocumentDB, push all the data. But you can do it anywhere you want with your own custom business logic.
Okay, thank you, Geert. So if you want to do real-time analytics in Azure, you can have a look at either Stream Analytics. It is very simple, easy to use, and if it fits your needs, be sure to have a look at it. If you want to have the full coding experience, the full control, all the bells and whistles, then be sure to have a look at the HDInsight offering with either Storm or Spark. Okay, that's it. Let's wrap it up, Geert, and see you next time. Bye.
Bye-bye.